So we are looking at section 2.2, problem number 19 from the homework. And this problem asks us to find the average rate of change of the function over the given interval. And then we want to compare this average rate of change with the instantaneous rate of change at different points. So the average rate of change is as you go from time t equals 3 to time t equals 4, how did your function outputs change? How did your f values change as you went to that with respect to the change in x? So it's your slope over that specific range. The instantaneous rate of change is a little bit different. And if you're working with a line, the instantaneous rate of change and the slope are going to be the same. In this case, the average rate of change and the instantaneous rate of change are not going to be the same. And part of that is because we're dealing with, well, in this case, we are dealing with a line, but they're not always the same if you're dealing with like a curved function and you're looking at how do you change over time. Here, if we look at our rate of change or our slope, it's not a direct line, so it's not a constant rate of change. It varies. If I go here, my instant rate of change versus here, sometimes it's negative change, sometimes it's positive. There's some fluctuation. So the instantaneous rate of change is just looking at that rate of change at a specific point, not overall. In this case, though, since we are dealing with a line, we're going to see that there's going to be some equivalency. But to find the average rate of change is just going to be that slope. Okay, so it's going to be essentially the change in y values or the change in corresponding x or f values with respect to the change in x values. So for the y values, we have f of 4 and f of 3 that we need to evaluate. If we plug in 4 into the function, we get 6 times 4 plus 3. We get 18, or 6 times 4 is 24. We get 24 plus 3, we get 27. And I'm kind of off the page there. $27. And then for f of 3, we have 6 times 3 plus 3. 6 times 3, we get 18, plus 3, we get 21. So our difference in y values is going to be 27 minus 21. And our difference in x values, we want to match up the corresponding x values. So 27 corresponds to x equaling 4, and 21 corresponds to x equaling 3. So we want to match those up. From there, we look at the difference. We have 6 in the numerator, and then we have 1 in the denominator. So these have an average rate of change of 6. So I can put that 6 in the box. Okay. Then we want to compare the average rate of change with the instantaneous rate of change. So the instantaneous rate of change, if you remember, is going to be the derivative, specifically at different points. So the left end point, that's going to be 3, and the right end point, we're going to evaluate that derivative at 4. So the instantaneous rate of change as a function is just going to be f prime of t. But we can see that if I take the derivative, we have f prime is equal to 6. So that instantaneous rate of change is actually not dependent on x. It's consistently 6. And that's because it's a line. A line has a constant rate of change. But still, we can talk about then, well, what is f prime of 3? There's no 3 to substitute in for t, so we just get 6, and then similarly with f prime of 4, we get 6 as well. So we have 6 and 6, and we complete the problem. Push the wrong button here.